Hi there. Hi, everyone. So we have Adam here today. Welcome to the... Okay, hold on. Can you hear me?
I can hear you perfectly. So can you see my screen? Can you hear me as well?
No, you need to share your screen.
I share my screen right now. Is it? It is shared. Yeah, it's shared. Is sharing your screens.
Okay, so let me see. I don't think we see Adam's screen. Can anyone see Adam's screen?
No.
No.
Now something happened. Wait a second. I have here now share screen.
Something's happening. Okay, almost there. I can see Adam's screen.
Perfect.
Okay, so just greeting again to everyone. It's fantastic to see all you on the chat. Adam is with us today. I don't think Adam needs a particular introduction, but I'll leave it to him as well. I just want to welcome you all. We're going to record this, and it is going to be available for everyone for viewing. If any questions, please type them in the chat, and I'm sure Adam will be more than happy to answer them. So I'll hand it over to Adam. Adam.
Yeah. Hi. Thank you for the invitation to the how it's called Jakarta EE Tech Talk. So what's the official name?
That's the official name, Jakarta Tech Talks.
Oh, perfect. So this nice. You are doing the marketing, so this is obvious. So now, Jakarta EE servers. Are Jakarta EE servers dead? So I hear this for almost 15 years, and I wanted to actually talk about that or think about this. And I think something like a tech talk is a perfect venue. So today the camera is not running, just to have more room for my slides. So now I really like Java still. And I think in 2019 was one of my busiest Java years, and I do a little bit also of JavaScript, but yeah, still 80% Java, I would say, or 70%. And what's interesting, so something newer is my podcast, where I interview interesting people, like, for instance, Tanya. And my blog is more or less like a notepad, so it's just personal blog. I got lots of requests as a guest articles. I rejected everything, so I just write things not to forget, in future. So and Airhacks TV is probably most interesting to you. What the Airhacks TV is like the monthly question and answer show. So my mantra is learn once, never migrate. This is the basic idea. This is what I do for years. It's just people ask me how to keep being up to date, and I would say you will have to learn something and stick with it for a while. And the hypes are coming and going, but something like standard or quasi-standard mostly survives. So this is what also happens with Jakarta EE and also happens in web standards, for instance, right? So this is the Airhacks TV. This year, it starts at 8 p.m., not 6 p.m. It is easier for me because of the workload. And yeah, this is the first Monday of the month, mostly, and this is 8 p.m. You don't have to register. You can just attend and ask questions. So now, some online courses. So about this session here. And Tanya, by the way, how long is the session? 1 hour, 45 minutes? What's planned?
Yeah, it's 1 hour.
1 hour, perfect. So we had a chat with Bruno Borges about MicroProfile in the clouds and serverless. And for me, Jakarta EE was actually, so from the conceptual perspective, this is a serverless technology. Why? Because we actually don't care about the servers that much. So we how to think about that? So in my projects, so people ask me now what to choose: OpenLiberty or Payara or Whitefly or Tommy, and I don't care a lot. So okay, pick whatever you like and just start coding. So the application server, every application server comes with added value, but the added value is important for later, not if you just focus on business logic. The added value are like supports costs or specific features or provisioning or deployment or integration with some SSOs. So this or caches. So this are monitoring stuff. These are the added value, but it doesn't matter if you start coding. So the idea is pick one server and here we go. So and why it is why it works that way? Because in Java EE we have the Java EE API or Jakarta EE API, and if you know the API, you can start coding. So what it actually means, if you have our WAR, this web archive, we can put the WAR to deploy the WAR to application server or somewhere else, and we would expect the WAR to run. And if you look inside the WAR, so what usually we have there is like JAX-OS endpoint. This is with get, post, and whatever, with a little bit JSON-B, to expose stuff. And it gets invoked by the application server, but it could be invoked by a cloud or whoever. We don't actually care about the application server that much. So in my project, it's like, you will see probably today, even I will just reinstall application server, and it will just, drop the old application server, reinstall the new one, and we are ready to go. So the application servers are more like cattle and less than pets. So it's actually for me, it's a prototypical idea of serverless. And even if you think about Google App Engine, which was one of the first, prototypes of, I would say, almost serverless, it was also very similar to application server. So, and I had a chat with Bruno Borges about that. And what I found out is, this was a really interesting conversation with him, because I talked all the time about the servers, and he talked about runtimes. And also in the Jakarta EE mailing list, I remember at the beginning of the Jakarta EE stuff, there was discussion, should we rename, not talk about Jakarta EE servers rather than about Jakarta EE runtimes. And I ask, what's the point? What's the difference between a server and a runtime? And I don't even see the difference. Or what's the story behind? And then occurred to me that application servers, what it actually means is, it in the name, it implies there are multiple applications on a server. So a server, it serves applications. And runtime, it implies one-to-one relation between an application and the server. And this was also true in the discussion with Bruno. And I thought, okay, this is actually right. So, and the problem is probably, I talk all the time about Jakarta EE or Java EE servers. And people say, okay, servers were that. And what they probably meant is that in the microservice world, there is a one-to-one relation between the server and the application, and not one-to-n between the application server and the and multiple wars. So this is the idea. And so this was like interesting conversation. If you like, you can re-listen to it. But we cover this a lot about that, and also we talk about cloud events, for instance. So Bruno said, okay, in the cloud we get events and they are executed by a functions. And I say, okay, but in application server, it could happen the same, right? So we have a JAX-OS resource, and this JAX-OS resource is invoked by someone. It could be a cloud event or not. I actually don't care who invokes my JAX-OS resource. Actually, on my server, this is the Apache web server who invokes the JAX-OS resource, for instance. Okay. So now, by the way, this was the announcement on Twitter, and I just retweeted that. Our application server is not, and the first reaction from Mark Teufel was, no, they are not. And my reaction was, this session is not going to be that short. So there is something to talk. So of course they are not that. Otherwise, Payara would just disappear from the internet. So, but it's this interesting discussion, to what actually happens right now. So now we have Jakarta EE and we have a MicroProfile. So we have two specifications in as Eclipse, or two specifications. There are two specification collections, I would say. And for me, the Jakarta EE is just like more stable, almost like an operating system. So I would expect more stability and not too much innovation, I would say, because I mean, the problem is how to innovate. If you look at CDI or JAX-OS, they are almost complete or feature complete specifications. It is really hard to invent or to extend the already existing CDI specification, or let's say JPA. So, and there are already mature technologies. Of course, there will be always some features, but it's not like, I don't expect a huge revolution in Jakarta EE10, let's say. So a little bit different is the MicroProfile. So this is the MicroProfile 3.1, and if you look at that, so at the bottom there are actually Java E8 specifications, and the upper part are actually more or less cloud native foundation specification, where we cannot control that much. So what it means is, if we cannot control this, we need more frequent releases, because let's say if matrix changes, these open telemetry format, we cannot control that. So we have to know to keep up with the non-Java communities. This is not about Java. Exactly the same with JSON Web Token. Of course, REST client, we control it completely. Config, we have more control over that. Open API, not that much. Open tracing, fault tolerance is also a set of patterns which we could actually implement. And the bottom part is the, I would say, the integration with Jakarta EE. So now, what is that? This is 18K. This is one of the slides from my microservice workshop. And what's interesting here, as you can probably see, this slide is fairly old. So actually, I wanted to buy this machine for myself as a container for my clothes. So it was cheaper than actually IKEA closet. But if you take a look on that, it cost back then $1 million. And right now it was $2,000, so it was really cheap. And back then dollars were very cheap for euros. The dollar and euro relation was good. But why I'm showing you the slide? The main idea or the added value of application servers back then was saving costs and money. So if a single machine costs 1 million, and I was in around the year 2000 in a project, we had 2 such machines in a cluster. So 18K, it was insurance company. And you can imagine we have 2 million euros in 2 machines. So the application servers were installed on such machine. And the main idea was to install as many applications as possible on a single application server, and provide isolation for the applications to keep, the hardware costs low per project. So this was the main goal of application servers. So the problem with this is the hardware becomes cheaper and cheaper. So right now, I think the same machine would cost like 20 euros with the same power. It's probably, I assume, so the 18K is probably a little bit faster than Raspberry Pi, I guess. So you could have no equivalent machine for 30 euros. And the question is, what's the point of application servers? And the remaining point, from my perspective, is ease of use. So what happens over the years was, we got, so if you take a look a little bit on the history, so my impression, so I followed this a little bit at the beginning, or I had to follow because I was in projects. So everything started with JDBC, which was a part of JDK actually. And my impression was like, it was a little bit driven by Oracle. And the Java database connectivity was similar to ODBC back then. And the idea was to abstract from databases. Then JNDI came in, JNDI, Java Dynamic and Directory Interface. It was like abstraction from directory service like LDAP, and Novell was behind back then. NDS, Novell Directory Services, huge things in the 2000s was like, the ability to look up printers in the network. So it was a huge deal back then. And JMS came from IBM, similar story. We wanted to have an abstraction to talk to MQ series or WebCMQ, and we got JMS. So over the years, we got abstractions for many different products and concepts. And and we get everything at once as a Java EE API, or now Jakarta EE API. And this is convenient for me, because if the project starts, I can just, download the thing and just, keep going. So this is what's, so I would say the role of application server changed to be, a money saver, just to save hardware costs, and where usability actually didn't matter at all. At the beginning, actually, no one cared whether the application servers are usable or not. They were complex, but no one cared. And actually, before J2E, there was actually no way to deploy an application to different application servers at the same time, because they were completely different. So there was no persistence power tier, ball and JBuilder. There was a Gemstone. There was a Tenga server, which became BA later, and they were complete different servers. So there was actually no way to install, to deploy something to multiple servers at the same time. There was not even no web XML. There were no servlets. And I was involved in one of the first application servers. It was called the Java Web Server from Sun. And back then there was no web XML. So there was actually no way to configure the servlets properly. So you had, to put one jar, and this was the deployment of your application to the application server. Okay, so now over time, of course, the application servers became more and more usable, and the goal shifted to be, like the only one operating system for all applications inside a company, into a runtime, which became also smaller over time, because it gets, over the course of 20 years, it got, optimized over and over again. And of course, and what also happened, the vendors, started to compete with each other. So there was a White Flat had modules, then Glassfish became OSGI server, then OpenLiberty came out, become smaller. So there was like, the race to be the smallest or more nimble server on earth. And if something is small, it starts fast. So it is very convenient way to use this. So let's see whether there are some, chats. Yeah, Tenga refers to Central Java. Perfect. Cool. So I just to take a look now what's in the chat, so everything on the track. So this is one of my slides from the microservices, and this was like one of the best practice slides. And what I said is, we have a self-contained wars, one operating system, one server, one war, no dependencies, no jars. So this is like my default slide. This is how to run microservices in or outside cloud. So clouds do not matter a lot. By accident, this is actually a perfect way to run something on Docker. And my way to Docker was an interesting one. So I was, I think, one of the first Docker users. And why? I run on my own server. And the problem with the servers is, I'm not, I do not maintain my own cloud. So what I'm doing mainly is I'm experimenting a lot, and every 3 years I buy new hardware just for fun and migrate everything to a new hardware with new operating system and new ideas. And I always forget, what I did in the last 3 years, and the migration was always pain, not from the Java perspective, more like from the HTTP server perspective and all the network settings and all the stuff. So this was the hard part. And what I wanted to do is I wanted to migrate from Linux to Open Solaris. And why? Because Solaris had containers. And the idea was, to put my application servers to containers, and then just, export them somehow as a TARS and run them in the new Open Solaris server. And the problem was, back then, Oracle bought Sun, and Open Solaris was not an option anymore. But at the same time, I just searched for containers, and I found Docker. So, okay, this is not Open Solaris, but at least something similar. And I actually use Docker just for backup purposes. So the idea was, you can just save the whole container as a tar. And if I have a new server, I've moved everything to a new server. Or even back then, what I did, the server was empty. I developed everything on my development machine, just pushed everything to the servers, launched everything, and it ran. So, and what I recognized back then, that the application servers actually work perfectly well with Docker. And why? Because probably of the slide. Because if you have, if your entire application runs in a war, and the war has no dependencies, the war is tiny, because the entire API with the implementation lives already on the server. And if it lives on the server, there is nothing to ship, because everything is on the server, as I said. So what it basically means is, just a quick hack. So make it a little bit larger. Set up Jakarta EE project, and let's call it Tech Talk. Tech Talk. And by the way, the Jakarta EE archetype is in Maven Central. So sometimes it takes a week or two to index, but now I double checked and it should be available for everyone. So the name of the archetype is Jakarta EE Essential Archetype. And I will switch to Tech Talk, and just open the editor. And what you should see is, this is what we talk about today, is the Jakarta EE8 dependency, and this is the microprofile. But this is just provided. It means it's already on the server. So what it also means is if I will just build it, and then you will see that the Tech Talk war should be tiny. And of course, this is simplistic application, so it is 4K. It is tiny, but in my projects, more commercial projects, they are usually still tiny. I would say, in worst case, a couple of megabytes. So there is not usually under 1 meg. And why? Because the Java bytecode is pretty small. So now we did this, and now watch that. So if I convert this to, let's say, Payara, why not? And say Maven clean install, and Docker build -t. Tech Talks, let's say Tech or Jakarta. No, it should be Eclipse, of course. Eclipse, Tech Talk. Also wrong. Jakarta EE Tech Talk. Tech Talks. So so done. So this was the entire Docker creation. But so what I usually do is I just show the Jakarta EE Tech Talks. And as you can see, the magic here is that the most upper image are 4K, and it's just 4K. This is why it was so fast. And all other layers are ancient. So there's 13 months, and this was 3 years. So 3 years I created the base image, which is probably the CentOS 7, I guess. Then I installed Java. Then Payara was refreshed 13 months ago, so I was pretty lazy in this case. But you can see the uppermost image is my microservice. And this is what matters, because usually, regardless private or public clouds, we already have the whole application server in the private registry somewhere in the clouds. So it could be, on OpenShift, this is the private registry on OpenShift. In Kubernetes, you have your own registry. It could be in my enterprise projects, Nexus or JFrog, or Harbor is also interesting registry. And the point is, so this most upper layer, this is the thing, I would say. This is actually what I found out. This is actually the key to be cloud native, because if something changes, I only ship this what changes, and everything else remains stable. And also interesting is the following. So if you run this in production, in this case, I guess it is Payara 5193. So what I can do, I can buy support from the Payara guys, and I say, hey, what is actually the libraries inside 5193? And I get a list. I get a list of the libraries, and I can find out whether there are some, security problems or stability issues or whatever. But if I would run everything in a war, the question is, what is inside? There is no clean separation between business logic and infrastructure. So it's way harder to know what's inside. So I will have to use, a lot more labels and annotations in Kubernetes or OpenShift to find out what's actually inside, which is already an issue in some projects in production in DevOps. So this is my way to Dockers and application servers, and this is the accidental, enlightenment. Actually, application servers accidentally, because we have the deployment process, are perfectly suitable for Docker environments, and so, of course, in Kubernetes. And if something runs in Kubernetes, it is actually appropriate to run well in all clouds. So this is the main idea. Okay, nice. So we did that. Of course, if we all start, it will start, of course. And by the way, because I mentioned that, so what I usually do before a project, I reinstall Payara. Now my Payara recent one, I think, is 193 or 4, or I can do the same with Whitefly. And what happens then is just, the old server is deleted and the new one is installed. So this I do it all the time because it's so easy. So I would say, the main goal of application servers became ease of use, usability, and I can focus my application, so my code becomes simpler and simpler. And I'm working a lot with startups, and what they tell me is actually it's very easy to work with application servers. And one funny question question I get is why the application servers are so fast. They never optimize anything and they just run fast. It's like, okay, because if you focus on business logic usually, and you don't write complex code, you don't try to optimize things, usually it runs fast. Okay, so we covered that. So what's the issue here? So the question is, are application servers dead, right? So the problem is, what I see is the multiple wars in an application server is no more a feature. So in 90% of all time, there is one-to-one relation between application server and the war. So what it means is I don't care about the deployments that much anymore. So for me, it's very important is the clean separation between business logic and infrastructure. But whether the application server can, isolate one war or 50, I don't really care, because in 80, 90% of all cases, I always have one-to-one relation between both. Okay, so this was actually the idea from also the slides. And now take a look what what it basically means is what is the future? The future in my eyes is we get something similar to let's say hollow jars with Pyra Micro or prior Tontail, or to something similar to Helidon or Quarkus. Why that? If you take a look, let's say on Quarkus, just to compare Quarkus, which is very recent runtime, and compare it to Jakarta EE. So if I would launch the Quarkus here, and this is the old one, this is 111, and let's say airhex and Quark. And just run it, just build that. The tests are a little bit annoying. So there are system tests. So now fixed. Now what we have here, just to compare that with the SynWar, we have a runner which is 170K. So as you can see, the jar is small, but not as small as the war. Why that? Because this contains the main method and a little bit of bootstrap code, as well as my application logic. And by the way, the application logic is also tiny. So if you take a look on that, it is very similar programming model, or the same programming model like Java EE, but different runtime. And if we take a look on that, main Java here, so it is like a JAX-RS, so there is actually no difference from the programming perspective. And so if we take a look on that, this is the one runner, which is executable. So there is no more application server. So you can say, okay, you preach 1 hour and you talk about how great it is that we have the separation between infrastructure and business logic. But if you take a look on the lib, target lib, this is where all the libraries reside. So the interesting part is what happens here is we have still clean separation between the business logic and the infrastructure. So what is very easy, you can just pack all the dependencies to a base Docker image, and then ship several times a day just the jar. So it happens naturally. The same is true for framework like Helidon. So I would just like to show you both. So we are talking right now about Quarkus IO and Helidon. So both are very similar. Helidon comes more from Oracle and Quarkus from Red Hat, but Helidon is more like a library, and the and Quarkus comes with executable jar. So and Helidon can be also executable, but there's also Cumulus, another one. Just do it. Let's go. Cumulus. So there's the Cumulus, also similar framework which supports MicroProfile and also MicroProfile plus Jakarta EE technology. So there is both are supported. And the interesting part in these frameworks, so what they do is they do like, application server plus. They say, okay, if there's only one relation, we have still the separation. We cannot ship, 2 applications per runtime anymore because no more necessary. But there is no deployment at runtime. So what's the problem with deployment at runtime? Actually, not a huge problem, except this is unnecessary complexity. So what the application servers have to do, they have to scan a folder, and the folder, what usually happens, they scan the folder, they find a war, they read the war, they decompress the war, and per reflection, they read all the stuff. But if the application server knows, okay, there is only one application, they can already read the application at the build time. There is no deployment involved. And this makes sense for specific environments, like, for instance, microservices or microservices, like, a small applications or clouds. And what the application servers or the newer runtimes begin to do is, like, for instance, Quarkus, they say, okay, if there is no more deployment at runtime, we can deploy at build time, and they try to optimize more and more at build time. What I get out of that is because there is no more reflection at runtime and lots of stuff going on at build time, they can, for instance, check whether the dependency injection will work, because if there is no unsatisfied dependency error or ambiguous dependency error, we will find that at build time. There's no, you don't have to wait at runtime, and the runtimes become even smaller because the whole deployment machinery is no more necessary at runtime. So this is what starts to shift. So I would say the name application servers, I guess it is that, or will disappear, but we will get a similar or exactly the same technology, and named differently. So there will be no Payara server rather than Payara runtime probably, or Whitefly runtime, or Whitefly gets replaced with Quarkus. But as you can see, for instance, in the Quarkus case, this is a lot of Netty, Quarkus, and if you Whitefly. So this is actually like the Whitefly technology repackaged and re-implemented differently. So okay, I would just take a look at the chat. Yeah, so Aryan says is the supported version of Whitefly is JBoss EAP. This is true. And someone asked me, I have looked at JE or... So Jayesh said, sorry to ask you a silly question. Is being a while, I have looked at JE. So if you ask me questions, please as short as possible. Otherwise, to reread them. And he said we can separate the business logic from dependencies before. It was harder. Also before, I think, no. I mean, how to do that, right? So with application servers, with deployment, it is a clear cut. So I mean, there is a war. There's no dependency on application servers, and the war is explored at deployment time. Without a war, it is a way harder to be clean. What I remember is the OSGI days back then. It is, I know most of the projects were not that clean because there were always tricks like body class loading, so I think it is really, the war was actually a huge success in my eyes. So question to the left in my pop-up. So Whitefly 19 is in the pipes with full MicroProfile support. Yeah, and Whitefly 18 also comes with partial MicroProfile support. Payara comes with full MicroProfile support. It's perfect. And by the way, I use Payara all the time. It's not like I say, okay, it's not usable. So what I'm just saying is like, in my last Payara projects, there was always, you know, one-to-one relation between Payara and War. It was the same in Whitefly. Ask question. So someone asked me, are you think that application server in Docker is a good idea for production usage? In real world, we need to set up application server only once and then just update deployment. Yeah, but this is the whole point. With application servers, the great story is, let's see, wait a second. Let's say whether I managed to do that. Registry. Okay. Docker remove registry. So now I would like to try to answer the question with some code. So now the Docker registry is running, and Docker images. So there was one image. This is this one. I will have to tag that. So Docker tag this one with one localhost 5000. And this, I think, is right. And then, with a little bit of luck, let's see what it works. It doesn't work always. It depends on the network. Docker push to that. Cool, it works. So what I'm doing right now, I'm actually deploying my application server to imaginary cloud. So this cloud runs on my machine. But what I'm doing is a remote push to Docker containers. And the question is it worth to use Docker? And the application server do not change all the time. So now the cool story is, so if I go to the tech talk again and perform some change. Oh, this was mistake. Wrong button. Do the same. Let's say I'm in the tech talk, and let's go here and say this is Jakarta E9, of course. So Jakarta E8 is old stuff. So we are already in Jakarta E9. So we have that. And now watch this. I would like to rebuild it again. Maven clean install and build. And I will build with the right name. Localhost 5000. Now it's built with the different tag. And then let's push it again. As you probably saw, it took like, 10 milliseconds to push. Why? Because Docker recognized, there is only the last layer changed and only what change was pushed. So it's very similar to Git, or if you like, blockchain almost, right? So, yeah, that's the difference. So let's see what else. So it's a very good idea, and I would say 80% of all my clients are running application servers in Docker. I would say 90%. I actually can't remember anymore who runs application servers on bare metal. So all my projects are running in Docker, and I would say like 50% of our projects are running on Kubernetes-like environment. Most of them OpenShift, and the others in the clouds. Next question is from what do you think of running servers on AWS? Yeah, sure. I mean, actually, at AWS, what do you mean by that? Is EC2 or EKS works perfectly. This is Elastic Kubernetes Service. So this, you can do this. So it's similar to OpenShift. And Google Cloud, a little bit more convenient, I would say. And Microsoft Azure, a little bit more popular. And the question is Lambdas. Lambdas is serverless, or function as a service. And the funny story is, in a Vue project, we find out that running application server all the time. So first, application servers, the runtime is smaller than you may think. And in this particular project, it was cheaper to run Payara all the time than because the traffic was high, than use, for instance, the Lambdas from AWS. So this is the question, the answer to this question. So next one. Ariane ask is it impossible EJB retired? So I think, is it possible that EJB retired? Yeah, I think we first, my personal opinion is we should retire as much as possible. And before we retire EJBs, I would retire SOAP first. This would be my absolute favorite. So it should just disappear from Jakarta EE. We can keep it in Java 8 and should disappear from Jakarta EE. So SOAP, this XML, RPC, and all the stuff, we don't need it. So the next one is easygoing's EJB. I think EJBs was never a problem. We have Arjan from Payara. I guess that the entire EJB container on Payara is like 1 meg. So there's actually non-issue with EJBs. But we should retire EJBs because CDI is good enough. So what we should include, all the annotations from EJBs, we should pull over to CDI, and then we are good to go. So the more specification we can kill, the simpler and more usable Jakarta EE becomes. And I really like EJB, but if CDI offers me the same annotations, I actually don't care whether they come from JavaX EJB or Jakarta.enterprise CDI or whatever. Yeah, and Arjan says exactly that. Roles allowed, or probably it would be a good idea to have pullable CDI beans. Also, I have to say with MicroProfile fault tolerance and bulkheads, we have something similar already in MicroProfile. So message-driven beans, this also can be a CDI replacement, yes. And even, for instance, in MicroProfile, it's called reactive messaging, I think. We are very similar with outgoing and incoming annotations to message-driven beans. So Google Clouds, Alexander says, yes, Google Clouds is even more usable than AWS in my eyes. So it's, cool crowd here. So other questions? So Jayesh, your question was not silly at all, was a good one. It's too long. Sorry for your long questions, you have to say. So pipeline 19, the pipes. Someone from Red Hat told me, okay, no, the MicroProfile full support is around the corner, and this was like November. So I would say right now I would expect, Whitefly delivering MicroProfile already. So now what else? Question I can answer. So Maven clean install is my bad habit. Yeah, I know that. I don't trust Maven a lot. I had already some discussions with Maven committers, like Robert Scholter, for instance. But yeah, my way of going, sure, Maven package should be enough. Sorry for that, for a clean install. A running joke, actually. Yeah, so I think I covered all the questions. So what is the... If you have any questions, so keep asking. So I have no idea why we have to, probably this is question is the chat. So this is the difference. Okay, so what's the gist from the whole story is? I would say, in my opinion, so the name server is problematic because people expect server like serving applications. So multiple applications from one server. And by the way, as I remember, it was I think it was even the same company with which ran the E10Ks back then. And in one point of time, someone said, we get an application server. And I say, okay. And someone else, from the department with non-Java programmers, is like, COBOL and PL1. And someone asked, okay, great. Then we can install Word on the application server. Like, what you would like to do is, the idea was back then that they install, the Word or Microsoft Excel on the application server, and they will just magically be distributed to the entire company. So this was the very first idea of application servers. So and now, so therefore, the imagination. If someone says application server, it means okay, there are multiple. So this is problematic. So I would say, from this point of view, application servers, are conceptually that. The problem with application servers, or the feature of application servers, they are just, very well optimized, very good runtimes and very usable runtimes. So now, what about testing in Jakarta? Is there any plans for testing? I mean, testing is a solved problem. So you can, launch all the specifications separately. And we had lots of discussion around testing. I even recorded the entire course about testing. And testing, I would say, is solved issue. What's usually the only problem with testing are the statistics. So most of my clients try, to unit test everything to get nice statistics. But what really counts in such projects is more, I would say, system tests, black box tests. And then what we do in testing is we have a pipeline, like a Jenkins pipeline, and the application gets deployed. We wait until readiness probes are green. If they are green, we just launch our system test, which is written in unit tests, JUnit and JAX client, and we test the application from outside. So now Majid Mostavi asked me, EJB performance is better than CDI. How does CDI make performance better? So first, CDI gets more and more optimized. And in runtimes like Quarkus, for instance, it doesn't matter anymore because they don't use reflection for dependency injection. So the performance of request scoped injection is almost as good, or I didn't measure that, but I actually expect to be as good as the performance of EJBs. What about running Tomcat on Docker? So Tomcat is an interesting one because, funny story with Tomcat. I think it was also 5 to 10 years ago, was a project in Switzerland, and they say, okay, we have a lightweight runtime because they're running Tomcat. I said, okay. And as you probably may know, Tomcat is actually a small lightweight runtime. The problem with Tomcat is, of course, there is just Servlet API on GSPs on it, so nothing else. And the war back then was 500 gigs. So they have a 500, no, sorry, 50, no, 500 gigs. Not 500 gigs. 500 megs, half a gig. Exactly, half a gig. It was incredibly large, and it took forever to deploy. So what happened with Tomcat back then is, that the runtime was small, but the war was larger than the application server, which is crazy in my eyes. So the deployable should be smaller than the runtime, and in Tomcat it was larger. So I never got the point of Tomcat or Jetty back then, because for me the simplicity was, have larger runtimes, usable runtimes, and ship smaller apps. My testing presentation, if you go to airhacks.io, there's Java EE testing course, like 50 sessions just about testing. And on my YouTube channel, you will also find lots of testing stuff. Horizontal scaling, I would say as Java EE application servers versus Spring, I would expect similar performance. And Node.js, I would say Java EE or Spring or Jakarta EE should be faster than Node.js. So this is but yeah, the problem with what I can tell you is, so average application server, with average application server, you can have several thousand transactions per second. And recently, if you go to my YouTube channel, I measured Quarkus versus Whitefly and performed a small benchmark, and there were 5,000 transactions per second right away. And this is what I also expect or see in projects. This is the performance. Exactly, Tommy makes absolute sense. So Tommy, where I could actually run Tommy in a Docker, just running Tomcat is pointless in my eyes. So which MicroProfile capable application server do you recommend preferred? The good news is all application servers except Whitefly, which is funny actually, because they have Quarkus, they have SmallRye. It was also a Red Hat effort, and the application server is not fully MicroProfile capable. So I made a very good experience with Payara. So I have lots of Payara projects. The reason being is I did a lot of Glassfish back then. Then OpenLiberty is just great. So it's very fresh, very modern, very fast application server, OpenLiberty. Then you're asking about application servers. Tommy is also nice. And Whitefly with some SmallRye patches is also great. And we all waiting for Whitefly 19, seems like. And by the way, Payara Micro, I never used Payara Micro. My problem was the Payara Full was small enough. And because Payara Full is based on Glassfish, I expect, or my idea was, if you just use Payara Full, we will find more documentation and we will find more answers to problems even from Glassfish days. And this is why I always propose Payara Full and always use Payara Full, and it's good enough. Exactly the same with Whitefly. I always use Whitefly Full, never Whitefly Web or whatever. It's just the problem what application server have is they are just good enough or small enough. So, no more questions. Cool. So, if you have just remaining questions, ask me. Otherwise, I will wrap up. So, what I actually I could code something, but I code usually all the time, so we just end up having another hello world. But Sergi has a question. Okay. What is your experience using Jakarta EE in combination with OpenShift is actually great. So what it means right now is if I do Payara, wait a second. So Payara S2I, and let's call it Tech Talk. Let's see, it won't work. I know it already. So what I would like to do is the following: mini shift console. Hopefully it runs. It runs. This is great with Jenkins, unfortunately, so it consumes a little bit of memory. So now let's try to do that. And what you see here is the following. You see that the server is not in my Docker registry. Or it is. It was just slow. It had to wake up. So this was the full deployment of Payara full from scratch. It took a little bit longer than expected, so I was a little bit unsure. But now the Tech Talk is deployed with Payara full on OpenShift. I use it all the time, and you see here the Jenkins ephemeral. If I would prepare myself for the talk, I will show you a pipeline running on it. And so the experience is just great. So you can run. I have Payara full, usually what I run on OpenShift, and Payara micro. Some of my clients would like to have it, so I do it as well. And let's see, with a little bit of luck. No Jenkins. If I go to routes, this is the Tech Talk route, and this is Payara in the cloud live. So, and this was, I think, a Tech Talk resources and ping. As you can see, this is the modified version, Jakarta E9, where I modified. So we deployed during the talk on Docker and on OpenShift. And yeah, the experience is just great. Why it was so fast? Because the Payara was already installed in the private Docker registry on OpenShift. So if we go to the OpenShift and go to images, you see the Payara S2I 5 days ago. So was already installed. So I refreshed my environment 5 days ago. So reinstalled everything. Okay, cool. So as you probably saw, you can even deploy to OpenShift during Tech Talks, which speaks for the usability of Payara and OpenShift. So now, yeah, cool question. So wait a second, where Sergi? I have to scroll, you see. So the application servers are easier to use than the chat software for me. So now go from, so this was this one. So we covered hopefully from Martin. So the experiences of Jakarta EE and Whitefly. So OpenShift comes with Whitefly S2I as well. So out of the box, and yeah, it works perfectly. So this is what I can tell you. And with of course, MiniShift is even MicroProfile is even better because we get readiness and liveness probes. And with both probes, they are crucial. Readiness probes in order the OpenShift has to find out when the application is ready to serve. And by the way, this is one of my criticism of normal application servers, I would say, because if you deploy application server to OpenShift, they become ready, and then the war gets deployed. So it was fixed in MicroProfile, but at the beginning, the application server said, I was ready, also the application was not deployed yet. And if you go with the runtimes, like Quarkus, Helidon, there is no more separation. So either everything is deployed or nothing. Yeah, which MicroProfile capable application server you recommend? Actually, all application servers except Whitefly, because we have to wait until Whitefly 19. All others are really greatly supported. And you saw the Jakarta EE API or Jakarta EE project, what I wrote with the archetype. I always use Jakarta E8 and MicroProfile. I never had just a MicroProfile project or just Jakarta EE project. Doesn't make sense, the separation. I always use both. So, next question. What about the new MicroProfile reactive messaging spec? It was not included in the last MicroProfile update. It was not included, but we already use it in one Quarkus project. And what about reactive messaging? I mean, if your application is already reactive, it makes sense if you're using reactive sources. For instance, in one project, we have to use Kafka. So it makes absolute sense, to read from the Kafka topic and transform, for instance, the messages to WebSocket. So this reactive programming is great. But if you just, have a normal database with normal JDBC driver and a normal JavaScript app, it doesn't make to be reactive at all. So how you prefer to share state in case not stateless application? So in case the application is not stateless, the question is what is your state? Is it your HTTP session? Probably not, because we don't need HTTP session anymore, except you have JSF. In this particular case, if the database is fast enough, store it in database. If not, probably something like Infinispan in case of Whitefly, or Hazelcast in case of Payara. That's what I would store the state. But I would try to keep the state. Yeah, exactly. I would like to keep the state, the application stateless first. Yeah, with JSF. And usually what probably will happen with JSF, I guess, is you would have two microservices. One microservice like the user interface microservice with JSF, and the other one backend service with microservices. Perfect. Yeah, Redis in memory is cool, but it's not well integrated. So we could do Redis, whatever. The problem with Redis is, of course, the license. They changed the license a bit. So it's cool, but could be problematic. So you have to be a little bit careful. So, yeah. I think we are done. I cannot find any questions anymore. So, so what's the conclusion? Are application server dead or not? So I think the conclusion is I always have to be a little bit careful what I'm talking about. So in my project, I always said, I'm an enterprise developer, and then I recognize actually then all my enterprise large projects, they look more or less like startup projects. So there is actually what also happened in the recent years. There is not a lot distinction between enterprise and startups anymore. Everything became more, I would say, more reasonable. So this is also one thing. So this enterprise, what enterprise probably just mean is more mature, probably, but no more this enterprise as it was 10 years ago. Cool. I'm actually done, I think. Yeah, and Tanya appears on the screen. And yeah, we're at the top of the hour. It was amazing as always, Adam. Thank you so much. And we'll talk to you on Tech Talk soon, but I just would like to take the opportunity to tell people that at the KubeCon Amsterdam, there is going to be CN4J Day, so Cloud Native Java Day, where you can hear more about Jakarta EE and MicroProfile as well. And we're pretty sure we will see Adam there as well. So yeah, please. I would try to come. I'm not try. I'm pretty sure I will come. I only have to think about a nice topic. But yeah, I would really like. Yeah, and I will chase you about that ASAP, because we want to start publishing and promoting. So for everyone out there, please
have your eyes open for that, and we're strongly hoping to see you there. And before even that event, we'll have additional tech talks. Get in touch with me if there is something you want to hear about or you want to present. I would love to put you on the schedule, and we can get you participating in Jakarta Tech Talks. And for now, again, thanks, Adam. Thanks, everyone dialing in, and we'll be in touch.
Yeah, thank you a lot.
Okay, bye for now.